This is Mansa. I'm studying BTech third year in Acharya Nagarjuna University College of Engineering and Technology. My teammates are G. Deepika, G. Katkeshwari, V. Sandhya Rani. We are presenting the project and micro oven simulator which is related to the Amadex Bangalore,
etc. And mainly we learn in this project are how to implement embedded C programming for microwave oven. Now we discuss what is embedded system. Embedded system is microcontroller or processor based system of hardware and software designed to perform a specific task within a larger electrical system. The some examples of my embedded system are ATMs, mobile phones, digital cameras, microwave oven. And in this project, we mainly learn about microwave oven, how to implement microwave oven using embedded systems and microcontrollers. There are mainly four types of embedded systems. There are real-time embedded systems, standalone embedded system, networked embedded systems, mobile embedded systems. The software we used in this microwave oven simulator are PiximLab Simulator, MPLab IED. Using MPLab IED, we wrote the code which is useful for the simulation of microwave oven. Then MPLab XIED is a latest version of MPLab and is developed on the NetBeans platform. PiximLab Simulator. PiximLab is a real-time emulator of development boards with integrated MPLab XIDE debugger. PiximLab supports some Pixim microcontroller and some SIM AVR microcontrollers. PiximLab have integration with MPLab XID and Arduino IDE for programming the board's microcontrollers. The components we have in embedded system are microcontroller, sensor, memory, communication interfaces, and power supply. And the next slide, we learn about the main components of embedded system. Like in this picture, we can mainly see that the all the components are connected to CPU in a grouped format, like in embedded. Like there are sensors, interfaces, ARD convention, FPGA software, memory, power supply, power cooling, diagnostic port, actuators, external environment. In Pixim simulator of over micro oven, we have these many types of modes. They are power on. By using this power on, microwave oven displays the power on message. The cooking mode. Cooking mode contains four types. They are micro mode, grill mode, convention mode, and start. And we also have set time or temperature. The microwave oven needs to facilitate the user to input required cooking time or temperature, so that we can see that the microwave simulator is working in a particular format. And the Piximulator issues a warning we need when the input invalid time or temperature is given, and end time. By displaying the end, we get this cooking time is up, so that we have our cooking time is completed. So our micro simulator is processing. And as we know, the cooking modes are of four types. Now we learn about micro mode. By pressing a key 1 in matrix keypad, micro mode is selected. The CCLD displays power is on, and CCLD promotes the user to enter the cooking time. Grill mode. Grill mode is selected by pressing the key 2 in the matrix keypad. By this, the CCLD promotes the user to enter the cooking time. And hashtag button confirms the time and starts cooking. Convention mode. By pressing the key 3 in the matrix keypad, convention mode is selected. By pressing the hashtag button, it confirms the temperature button. Oven starts preheating with the given temperature for 3 minutes, following which promotes the user to enter the cooking time. Interfacing. Interfacing refers to the process of connecting more devices or systems together to enable communication and exchange of data. In the context of embedded systems, interfacing typically involves connecting sensors, other components to a microcontroller, or other processing units. There are several ways to interface devices together. There are serial communication, parallel communication, wireless communication, USB, and Ethernet. And this PIC 167877A architecture has its own features that its operating frequency is of 20 megahertz and it has 5 input output ports, 3 timers, flash memories of 8 KB, data memories of 368 bytes, and as well as it also has 5 input and output ports. CLCD. CLCD stands for Character Liquid Crystal Display. Through this, it displays the technology which is commonly used in electronic devices such as calculators, digital watches, and small applications. CCLD is a liquid crystal to display characters and numbers, providing a simple and cost-effective solution for displaying information. In the above picture, we can see that uh, the CCLD displays these characters and numbers so that we can distinguish which of the button is pressed. CCLD is of 8-bit mode and 4-bit mode. CCLD has mainly it displays 6 by 2 and 6 by 4 modes. In our project, we commonly use 6 by 4 display. It has total 16 interfacing lines in which D2 D7 are data lines. It has built-in controller and it has its own ROM and RAM so that controller can be executed. In this RS line represent a register selector. If register selector value is 1, we get the data. If register selector line is of 0, we get the instruction to the config simulator. Data processed by two methods in this CCLD. They are delay method and pooling method. Pooling method means we want to observe a pin, in our case D7 pin, and in this read or write equal to 1 minus read and read or write equal to 0 minus write. And in 8-bit mode, the data lines are from D0 to D7, and in 4-bit mode, data lines are from D4 to D7. Tactile key. A tactile switch which allows the electricity to flow in an electrical circuit by manually pressing the operating section. The switch is used to supply input signal to a device or an equipment. It's a design with a small footprint situated or mounted on the surface printed circuit, which is known as PCB, made to connect electronic components to form electronic. A tactile is also known as memory push button, and it's a switch that is designed to press briefly or break in a electrical circuit. We can say that tactile switch is a switch which is used to break the electrical circuit and is also known as a momentary push button. It is commonly used in various electronic devices and systems to provide user input or control functions. In a matrix keypad is a common implementation of tactile switch. It consists of grid buttons arranged in rows and columns, with each button representing a specific key or input. A matrix keypad are typically arranged in a grid pattern, with each button connected to a specific row or a column. When a button is pressed in this matrix keypad, it creates a connection which is which connects the row and column, which can be detected by the system. Timers. There are mainly three types of timers in PIC board. There are timer 0, timer 1 and timer 2. Timers can work as both timers and controllers, allowing for counting internal and external pulses. Timer 0 is an 8-bit timer that counts from 00 to 77 and then generates an interrupt. There are various registers associated with timer 0, that TMRO clock source select bit. There are 15 interrupt sources in the case of this microcontroller. Timer 0 has bit GIE. If we set this bit, it will enable all the interrupts present in the timer or PIC simulator interrupts. The interrupts are buzzer and fan. Interrupts occurs when a timer 2 register overflows. Buzzer connects to pin 1 of port C. Fan connects pin 2 of port C. Now, The demo of the project micro oven simulator is explained by my teammate.
Hi everyone. In earlier we learned about Pixim Lab and MP Lab theory part. Here I will discuss. Here I now discuss about practical knowledge on this. Here we are shown a code we run in a MP Lab and it is successfully completed. After this we are moved to a Pixim Lab. First of all we have to reload it. After reloading, we display like powering on microwave oven. After this, we have different types of modes: micro, grill, convection, start, with numbering 1, 2, 3, 4. These are the tactile switch numbers. For start, for switching into micro mode, we have to click on tactile switch 1, and for switching to grill mode, we have to click on tactile switch 2, for convection 3, and start mode to 4. So first of all we have click on for micro mode, we click on tactile switch 1, then we display a power with 900 volts. Then first of all we have to setting a time we have set the time approximately near to 60 minutes. Here I setting a time up to 15 seconds. After setting a 15 seconds, we have to click on ash tactile switch. Ash tactile switch is used to start the process. After switching on tactile switch, the timer will start and the cooler is start to rotating. We have shown on the display. After completing the time, a buzzer sound will be blown and time up will be shown on the CLCD display. After completing the micro mode, we have to switch to the grill mode. For that, we have to click on tactile switch 2. For that, after switching to 2, the same process will be repeated. In this grill mode, also a time we have to set up a time. For example, here I set a time 20 seconds. In grill mode, we can set up a time more than 60 minutes. There is no more than 60 minutes any time. Here I set up a time 20 seconds. For starting, I click on Ash Tactile Switch. After switching on Tactile Switch Ash, the timer will start. For passing and stopping and starting, we have click on the Tactile Switch 4, 5, 6. Here also, after completing the timing setup, the buzzer will be blown with displaying time up. After this, we have to switch to convection mode. Convection mode is different compared to micro and grill. Convection mode is mainly used for preheating. In this convection mode, the setting time is fixed. Additionally, in this convection mode, we have to add temperature here. For converting to convection mode, we have to click on tactile switch 3. Here we have shown on the display we have to set up a temperature here. For example, here I set a temperature like 23. After that I click on as timing. The timer will start automatically because I already said that the timer is fixed. It approximately 180 seconds, that means 3 minutes. In this time I will give a brief introduction on Pixin Lab this board. Here we have different types of devices in this like tactile switches and microcontrollers, cooler, buzzers, and relay switches. These tactile switches are mainly used for mode selections. Here we have a 4x4 tactile switch display here. These are mainly used for mode selection, and microcontroller is mainly used for performing specific tasks. And buzzer is used for letting us know about the time completion. And relay switches are used for switching purposes, and cooler is used for cooling the device, and reset is used for restart the process from starting simulation. On clicking reset button, the which the process will be started from starting. Here we also see that the time is 105 approximately, and also we have different types of resistors and different types of displays are there. And RB3. RB3 is used for mainly for if the microwave oven door is open or closed. The switch is mainly used for that. If we click on RB3, it will shows information about the switch, the microwave is open or closed. And the display here we have seen a CLCD display, that is a 16 by 4 display. We have two types of displays here, 16 by 2 and 16 by 4. The 16 by 4 is more efficient compared to the 16 by 2, because in 16 by 4 we only get some information, like we can't see the more information. Like here we only see the preheating, we didn't saw the timing and how much time is remaining. In 16 by 4 we can see how much time will be taken to complete this process. So 16 by 4 is more efficient compared to 16 by 2. That's why we use 16 by 4 mode for this. And also it remains 25 seconds for completing convection mode. Three, two, one. Now the convection mode is completed. For showing up the modes again, here we are setting a time for starting. We are automatically start the start mode here. For that we here, for example, I setting up 20 seconds. After that I click on ash, then the start process will be started. It approximately I give a 20 seconds. It is less than the start mode will takes less than 10 minutes. Here the start and resume is used to, if we click on tactics 4 we can increase the time. For pass it is used to stop the process. Here we have also seen that the cooler will stop the processing. If we resume the process again, we have again click on the tactics switch 4, as shown like this. After completing this time, the buzzer will be blown and it will automatically display the remaining modes. So, in this, we all perform all micro, grill, convection, and start modes, and we are learning about the modes and how tactics are work here, and how we are run the code in MP Lab here. Here we switch to start by clicking on 4. We can done this process. After this, the system is ready for cooking. They are still 15 seconds are left. 5, 4, 3, 2, 1. Yes, time is up. Then we have completed the 4 modes here, and the process is that we have simulated